chemical equilibrium, guys, listen to this, it's very important. So today what I want us to look into really is chemical rates. What are chemical rates, guys, if I may ask you a question before we move on? What is a chemical rate, or how do we define chemical rates in a chemical reaction? Once you see the word rate, it means it's the change of the concentration of the products and the reactants. Do you guys see that? So it means how much of a product are we forming if the reactant is disappearing, how much of the product are we forming, or how much of the reactant is forming if it's a backward reaction. Are we together on that? So it's the rate of change of the concentration of the reaction participants. I don't know if you understand when I say reaction participants, I mean the reactants and the products. So you need to be able to define that. So what affects chemical rates? There are factors that affect chemical rates. First of all, the reason why we have that, we have to have what we call kinetic collision theory, meaning that we want to drive the reaction to happen faster, so we need to make sure that the reactants meet each other at a faster rate so that we can make the reaction fast. Do you guys understand that? And then how do we do that, if I can ask you one question? One, we increase the concentration of the reactants, yes or no? And then why do we increase the concentration of the reactants? So that means there are more particles per unit volume that will collide with one another to make the reaction faster. I'm trying to be slow today, okay? Did I make sense of that? Yes, we want to increase the number of particles per unit volume so that particles can collide faster. So once they collide faster, that means the reaction will be fast. That's why we increase the concentration. Is that okay? Secondly, what must we increase? What changes? What influences the chemical rate? Temperature, right? So if you heat up a sample, what happens to the sample? The molecules move what? So when they move faster, they collide. So when they collide more, the reaction is fast. That's the second factor that you guys need to really know. And how about the third one, guys? Do you guys know what we call a catalyst? What is a catalyst, if I may ask you?
It's something that lowers activation without changing the product.
Yes, sir.
Substance increases the rate of change but remains unchanged at the end of the reaction.
Oh, that's also a very good definition. If I can ask you one last question, what is the difference between a catalyst and an enzyme? Huh? What is the difference between the two? An enzyme is biological. I just want you to start knowing the difference now. An enzyme is biological, meaning enzymes are proteins. Do you guys understand now? But catalysts are non-biological. They both do the same thing by lowering the activation energy so that we can drive the reaction faster. Both themselves, they don't get used up. Do you guys understand? It's like, have you guys played that game? What do we call that game? Pac-Man, right? It eats, it regenerates. It eats, it regenerates. Is that okay? It's just that it gives out what? The product in the process. Is that okay? It does not get used up. Both a catalyst and an enzyme. So now you know something about biology, right? Because an enzyme is mostly used in biology. So please know the difference. Yes, ma'am?
Please say it again.
An enzyme is a biological molecule because enzymes are proteins. Catalysts are non-biological. Do you understand that? A catalyst could be platinum, an enzyme can never be platinum. Do you understand? But they both do the same job. So by lowering the activation energy, why are they lowering the activation energy? Good question. Do you guys know this thing called transition state? Raise up your hand if you know transition state. Okay. I'll probably not speak about it. So it lowers the activation energy by making sure that we get to transition state faster. Write that definition down. I'll explain now why am I saying that. At transition state, that is where old bonds are broken, new bonds are formed. Do you understand that? So it lowers the activation energy so that we can get to transition state faster. At transition state, that is where old bonds are broken because there's an exchange of bonds and new ones are formed. That means we are forming now what? A product. Do you guys understand? So it takes so much time for the enzyme or for the catalyst to get to transition state. So, but if we lower that energy to get there faster, it means the reaction will be faster. Is that okay? For example, the reason why we study chemistry is to apply it into the real world. Imagine if you're working for a company that makes aspirin. Do you guys know aspirin, right? And then we want to push the product so that now we can be able to sell it quicker, right? That means we must always try to have faster reactions. Is that okay? That means we must catalyze the reaction, we must increase the concentration, we must increase what? The temperature. Is that okay? And then what is another factor? Because I did speak of the fact that one of the factors is the concentration of what? Of the reactants, right? The second one, we said it's temperature. Is that okay? And then what is the third one that I mentioned, guys? It's a catalyst, right? So now you know what does a catalyst do. And then the fourth one, do you think gases react the same way as solids? Which one reacts faster? So do you guys understand now that we need to say is the nature of the reactants? Hello? Did you say something? Okay, so we say number 4 is the nature of the reactants. That means now, the nature of the reactants, I mean, is it solid, gas, or liquid? We expect gases to collide faster because the molecules move so fast, but solids do not do that. Do you guys understand what I'm saying? And then please guys, you need to be able to say the nature of the reactant, or we can say the surface area. Do you guys understand what I'm talking about? Think about a matchstick. Think about a matches. You see a matches stick. If it was this big and then you do this to the matches, do you think it was going to light faster than when it was a smaller stick? Do you think it was going to burn faster if it was the size of this pen than when it was small? Because this has a what? A larger surface than the other one that is small. So it affects the chemical change. Is that okay? So please guys, these factors, they are very important. You need to learn them and you need to remember them. Yes, ma'am?
So how would the nature of the reactants be the same as the surface area? Because for example, same powder would react quickly.
I can't, the mask, my bad.
So how would the nature of the reactants be the same as the surface area? Because, for example, zinc powder would react quicker than
a solid.
metals. So how is that the same?
So if it's a solid, which one has got a higher surface area between a solid and a gas?
The gas.
So isn't that the nature of the reactants? It is. I'm not going to say it is the same, but the minute you have a different nature of the product, definitely the surface area will definitely change. So I can then include surface area as the 5th one to make you sleep better. Is that okay? So I can say then surface area. I can do that for you, okay? It's also a factor, but I view it as by saying, I know that solids don't react faster because they have surface area that is different from gases, but gases move faster also. So it is a point. I will take it because you raised it, okay? Yes, ma'am?
So the nature of the reactants would be whether it's granules or a powder.
Exactly. That's very true. All right, so now since you guys already know what affects chemical rates, let's look into now putting these things into questions and try to look into what they need. Remember one thing that I mentioned yesterday. Every time there's a chemical reaction, write that chemical reaction, balance it, use what you have to solve for what you do not have. Is that okay? Unfortunately, the stoichiometric factors or the balancing factors, they play a huge role when it comes to chemistry. And you need to be able to balance. Okay, so if you look into question number 1 of our chemical rates, it looks like this. From whatever I gave you guys. Do you see that? Page number 29. Okay. They say here, question number 1, define chemical rate in words. What did I say? What is a chemical rate? A chemical rate is a change of concentration per what? Unit time. It's the change, I'll write it down for you. It is the change of the concentration of the reaction participants. So we can say it is the change of the reaction participants per unit time. That's what defines the term reaction rate. It's easy, right? Everybody can get that. And then the next question will come as follows. Let us use the reaction between impure powdered calcium carbonate and excess hydrochloric acid to investigate the reaction rate. The balance equation is, this is the equation that you're given them. They perform 4 experiments under different conditions of concentration, mass, temperature as shown below. They use identical apparatus in the 4 experiments and measure the volume of each gas released in each experiment. So these are the experiments that you guys have there. So what do you have? You've got experiment 1, experiment 2, experiment 3, and experiment 4. If you look into those, then we move on. You have got the mass now, right, of calcium carbonate, and then you've got the initial temperatures. So if you use this table and you apply your knowledge, what happens to temperature, what happens when it's solid, what happens when it's powder, what happens when it's blah, 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 you can be able to crack any question. Let's read the first question. What is it that they need? The results of experiment 1 and 3 are compared in the investigation. Write down an independent value and a dependent value. What are those two things, if I may ask you from school? What is an independent value? It doesn't get affected by the other one, yes or no? But a independent doesn't. A dependent value gets affected by the other one. You just need to learn that. So now they say here, write down the independent value for the reaction. What is the independent value of the reaction there?
Temperature, mass, or concentration.
I'm going to let others to shine. Backbenchers there. What is the independent variable? Anyone?
The independent.
The independent, yes.
The independent one of 1 and 3, right?
Yes. You are not wrong.
Okay, fine. It's the mass of impure calcium carbonate.
So it is the mass, it is also the temperature. Okay. So you can give one of those. Is that okay? It is independent. But now the rate of reaction is what? Dependent on those things. Do you guys understand that? So the reaction. And also, yes, sir. The what?
The control.
Do you guys do controls as yet? A control variable is something that you use to calculate the other one or use it as a reference point. What do you guys think that will be in here? Let me let that to you to think. Yes, ma'am? Could be. She's saying it's excess hydrochloric acid. What do you guys say? It's the stuff that you use to use it as a reference. It's a control. Is that okay? Which one do you guys think it is there? Yes? Which one? The change in temperature affects what? Concentration. So that is not a control. Is that okay? I will agree with you, okay? It is the excess hydrochloric. Yes, ma'am?
So the control of the experiment is the first experiment, but the controlled variable would be the concentration and the mass of the impure calcium. Because they remain constant, they are controlled variables.
Let me let the flow. What do you guys think this side? Because according to your scope, what I know, you just need to know what is a dependent and independent. Now I'm just learning that you need to know what is a control. What is the control according to you guys this side? Huh? We'll argue about this later. Let me leave it for now. We'll argue about this one. Okay. But I gave you the two that you guys need to know. We did say that here we can say it's temperature. Temperature. We'll argue about this as soon as possible. And then here we said is the rate of reaction there. That's what we said. And now use the theory to explain why reaction number 4, you guys see that, will be higher than reaction rate in number what? 3. You guys see that? So what must you look into? You need to look into what happened to the equation. Is that okay? I mean to the table there. I hope you guys do realize that in reaction number 4, the temperature the initial temperature is the same. Do you guys see that? And then do you guys see that now the mass here is more? Do you guys understand that? And then the mass is less here. Do you guys see that? Yes or no? Yes. And then do you guys also see that the concentrations are the same? So what is the factor that you can be able to explain this thing? So once you increase the mass, what do you guys increase? You increase what? The surface? Please explain that. Be able to explain that. So what we will say here, using this point, we will say now, the larger the mass, the larger the mass means there is a larger amount. Once you increase the higher amount, it means you are increasing what? The surface area. Therefore, because they said base this question on the collision theory, right? We really need to then talk about the collision theory there. Therefore, this means that there are more collisions is that okay? Per unit time. Is that okay? When there are more collisions per unit time, what does it mean? You need to then explain the last part. What does it mean when there are more collisions per unit time? It means more particles will collide with sufficient energy. Is that okay? Per unit time. And then you're done giving them the explanation for 3 marks there. So guys, please make sure you are able to do that. You're not gonna die if you try to explain everything that you need to explain in a question, okay? And then now they say, I should put it back. Okay. Guys, I did say please correct me if you feel like I'm fast. Please do that. Don't get tired of me. Okay? Please don't. Next year when you come to university, you will learn that everything works fast. So that when you get to class, there's no need for you to write. You just sit and listen. Okay? But this year, it's still good. Yes, sir?
So I want to know, would you say the amount of calcium carbonate in the nuclear?
So there's more, one of them is more than the other one. Once there is more than the other one, it means there are many particles per unit time. It means there are more particles per unit time. It means they will collide faster. When you go there, you meet another one. When you go there, you meet another one. The minute you do that, you gain kinetic energy. Once it gains kinetic energy, that means they will collide even much further per unit time, and then that makes the reaction faster.
So I can say it's because there are more molecules.
You can say that, yes. Shh. Okay. Now let's try and understand what the next question needs. The next question says, the learners obtain graphs A, B, C, and D from their results. Okay? Which one of the graphs A, B, C, or D represents experiment 1? Okay? Fully explain the answer by comparing experiment 1 with experiment 2, 3, and 4. What do you guys know about the rate of a reaction with the gradient? The higher the gradient, the faster the rate of the reaction. Let me let you guys try and figure that out for 1 minute. Compare now. Let me let you guys compare experiment 1 and experiment 2 and tell me, what do you guys think? Oh, I wrote the answer for you for this one. I wasn't supposed to do that. Let me let you guys, now you already know what the answer is. I shouldn't have done that. You guys copied. So guys, looking into the rates, let me just explain this so quick while we are at it. If you're looking into the rates of reaction, right? Between experiment 1, 2, and 3. Do you guys see that? And then you do understand that this is the fastest reaction. Do you guys understand that? This is faster than C and D. This is faster than D, right? D is the slowest reaction. Do you guys understand that? So now let's look into the information here. Looking into the concentrations, because I feel like the concentrations will give us what? A better understanding. If you compare experiment 1 and 2, looking into these concentrations, what do you guys will happen between this one and this one? Huh? Oh, Jesus, my bad. If you compare the concentrations of experiment 1 and 2, which reaction do you think will be faster? Do you think that experiment 1 is faster than experiment 2? Because experiment 2 has got a lower concentration. Is that okay? So then now if you compare experiment 1 and 3, what do you guys think will happen in there? Sorry, looking into the temperatures now also, because you need to look into all the aspects. So you guys see that 3 is faster than 1, yes or no? Yes. Do you guys think 1 is faster than 4 or 4 is faster than 1? 4 is faster. If you compare 4 and 3, which one is the fastest? 4. So would you agree with me by saying this is number 4, and then B is equals to? 3. And then B is equals to what? 3. This is equals to what? 1. This is equals to what? Are you not done answering the question? You are not done, but you did explain the fact that number C is equals to what? It's experiment 1. Then you need to explain why is it the case for those 6 marks. Then you talk about the temperature when you compare experiment 1 and 2, yes or no? When you compare experiment 1 and 3, talk about what's the temperatures. Is that okay? When you compare 1 and 4, also talk about the difference in temperature. And then you are done. Do you want me to write the answers for you? Yes. Okay. Do you want me to spoon feed you guys now? It's okay. So we say now the reaction rate in experiment 1 is faster than experiment 2. Why? Because experiment 1 has a higher what? Concentration as compared to experiment 2. You full stop. Then if you want to be extra, you can say the higher the concentration, the more collision. Do you guys understand that? And then, so we've done comparing experiment 1 and 2. Now we need to compare 1 and 3. Is that okay? Then we say experiment 3 is higher than experiment 1 due to higher what? Temperature. So the gradient is steeper. So the gradient is steeper in 3 as compared to 1. Okay, now we need to talk about 1 and 4. Is that okay? And then what do we say about 1 and 4? We say experiment 4 is higher than experiment 1. Why are we saying it's higher than experiment 1? Due to high temperature. The higher the temperature, you can explain that. The higher the temperature, what happens? The more particles collide and react faster. So that's what they wanted you to explain there. Then you are good to go. You have all the 6 marks in there. You need to read now the last question. The last question, I figured it was not fair for you, but I know you will be able to understand if you listen to what I'm going to say. So if you look into the question that you guys have at the top there, the equation reads as calcium carbonate plus 2 hydrochloric acid gives you calcium chloride, you have it in front of you guys, plus water and carbon dioxide. And then now the reaction in experiment 4 reaches completion. The volume of the gas formed is 4.5 dm cubed. Yes, ma'am?
So how the 6 marks are allocated?
2, and then saying the answer is C. Yes. So I was saying to you now, the reaction in experiment 4 reaches the completion of the gas formed is 4.5 thingy. The gas that is formed, which one is it, guys, according to the chemical equation? It's carbon dioxide. Do you guys see that? So now they're giving you the volume of carbon dioxide that is formed in them. And then now they assume that the molar gas volume at 40 degrees, of course it's 40 degrees, is 27.5 dm cubed. So basically this statement tells us something. Calculate the mass of the impurities of calcium carbonate. The one thing that I always mention to you guys, once you have got a chemical reaction that looks like this, what is it that they want? They want the mass of the impurities. Do you guys understand the fact that a compound, in this case the calcium carbonate, is made out of the pure and the one that is not pure? Do you guys understand? Do you guys understand the fact that the pure one is the one that is going to react? Do you guys see that? Think about this. You have a solution that contains sugar and soil. Do you guys know, like soil? You take soil and sugar. Is that okay? We call that our sample. We react that, or we dissolve that. What's going to dissolve? It's the sugar, right? That means the sugar is the pure, the salt is not the pure, it's the impurities. Do you guys understand? So what I'm trying to say here, the one that reacts is the pure, the one that doesn't react are the impurities. So they want the one of these that does not react. If we give you the moles of the gas, because the moles of the gas is given by the volume ratios. That's why I say I feel like it's not fair for you, but that's what they wanted you to figure out. Is that okay? So all we then need to do on that question is to say, can I take something to write here? Because we are given the carbon dioxide. Do you all see that? We are given the carbon dioxide this side. That means we need to use this carbon dioxide to find the moles of these. Once we find the moles of that, we convert the moles of that into what? The mass. That means it's the mass of calcium carbonate that reacted. Do you guys see that? All right, now let's do this together. Do you also understand, before you start with this question, that the amount of moles of carbon dioxide are 1:1 to the number of moles of calcium carbonate? Do you guys make sense of that? The amount of moles of carbon dioxide are equal to the number of moles of calcium carbonate. Yes or no? Why? Because there is one here, there is also one here. Do you guys understand that? And then how about the moles now of hydrochloric acid? There are 2 moles of hydrochloric acid per 1 mole of what? Calcium of carbon dioxide. Do you guys see that? So if you have the moles of carbon dioxide, in order for you to find the moles of HCl, you must multiply by. If you have the moles of carbon dioxide, in order for you to find the moles of calcium carbonate, it's equals to 1. It's 1:1. That means they are what? Equal. Do you guys understand that? So what this question needs you to do then at the very end of the day, find the moles of these and then come back to this, because the moles that are going to be found here are the moles of what reacted. Do you all understand now? All right, so how do we then get to do that? We come back, we say, the number of moles, I don't like this pen, it's too big. Okay, we come back, we say, the number of moles of carbon dioxide is given by the volume all over the molar volume, which is the Vm. In this case, it is equals to 4.5, divide everything by 25.7. And then the answer that we get there is 0.18. What are these? Moles of CO2. As I was saying, you use the volume ratios. It wasn't so clear for you guys, but you will be able to find it. As more as you practice, you will find the tricks to doing this. So once you find the moles of that, and then you come back, you say, therefore, number of moles of carbon dioxide are equal to the number of moles of what? Calcium carbonate. That means the number of moles of calcium carbonate is equal to what? 0.18 what? Moles. So you see now that you do have the moles of calcium carbonate. Once you have the moles of carbonate, what must you do? You must convert it into what? Mass. Once you have the mass, it's the mass that reacted. Do you guys see that? Let's do it together then, so that we can wrap this question around. Okay, before I move on, what is the molar mass of calcium carbonate? I will give it to you because I didn't print out a periodic table, okay? Shh. So please do not forget this statement that says number of moles is equals to mass all over molar mass. Do you guys remember this statement? So once we have that, we come back, then we say, what are we looking for? We're looking for the mass. The moles are given to be 0.181 moles. Therefore, mass is given by 0.18 moles times by 100 grams per what? Mole of calcium carbonate. The molar mass of calcium carbonate is 100 grams per mole. If you use your periodic table, let me show you how that was done, because some of you are still messing up. Guys, you don't multiply with the balancing stoichiometric factor when you're doing a molar mass. Some of you, you know what you will do. For example, I'm going to divert a little bit. Do you see the HCl there? This HCl. Some of you will calculate the molar mass of the HCl and multiply it by 2. Do you guys please make sure that you do not ever apply this stoichiometric factor when you're doing what? Molar mass. Is that okay? Do you guys get what I'm saying? Don't ever do that. So here you will say it is equals to calcium plus the molar mass of carbon plus 3 times the molar mass of oxygen. Do you guys understand that? Then you add those values, you will definitely get 100. Where do you get them? In the periodic. So this is going to give you 100 grams per mole. So this mole cancel this mole. So your answer that you get here is in grams. What answer do you guys get there? It's 18. Do you guys see that? It's 18 what? Grams. Is that okay? Is the one that is reacted. What did the question want? The mass of the impure. Is that okay? What was the mass before? Do you guys see that? Now you come back. You say, therefore, it is 25 minus 18 grams. The answer that you get there is equals to 7 grams. Good to go. Use what you don't have to get what you have using a balanced equation. Please make sure that you know how to calculate the molar mass, because some people do not know. You will not do well because you couldn't get this 100 here. Is that okay? Question 2, so that we can move quickly. So you have your 18 marks for free there. Let me let you guys attempt question number 2. So, a group of learners used the reaction of excess hydrochloric acid with zinc to investigate the factors that influence a chemical rate, of which we know all the factors, right? Yes or no? Yes. So now, once we know the factors there, it balanced with a chemical reaction there. And then check this out. They use a same volume of hydrochloric acid and they give you the mass of this as 1.2 grams of zinc in each of the 5 experiments. These are the experiments that were done in here. And then they ask you something. If you look into this, experiment 1, the concentration of HCl is 0.5, and then the temperature from 20 to 34, and then it's in a granular form. The time it took is 50. Do you guys see that? Yes or no? Yes. Okay, so what must happen in there now? As I was saying, in experiment 1, you have 0.5 concentration. The temperature was 20, and then now it becomes 34. And this is in a granular form, and the time it took is 50. Same applies to experiment 2. It's in a powder form. So you see why it took a shorter time, right? Because it's in a powder form, yes or no? And then now you come back to 3, 4, and 5. Okay. And then they ask you a question. I argued with myself. I will let you guys argue as well. Is this reaction exothermic or endothermic? Do you guys mind explaining to me what is exothermic? Please raise up your hand and educate the whole class. Yes, sir.
So, like gives off heat. So.
It what?
Endothermic, like cools.
Absorbs heat.
Yeah. So it's like a two-way reaction.
I argued with myself 1,000 times. I'm letting you guys argue as well. What do you guys, there's an increase in temperature here. Do you guys see that? What happens when you heat water in a stove? It increases the temperature, right? It absorbs heat from the stove. Is that okay? Is that an endothermic or an exothermic reaction?
Endothermic, because the solution is the surroundings became colder, technically.
Yes, the solution is becoming hotter, the surrounding became what? Colder.
So it's endothermic.
So it's endothermic.
Absorbing heat from
It's absorbing heat from the surrounding.
It says temperature
But if it
here in this table, it means that the temperature of the solution is increased. Therefore, it's an endothermic reaction.
That's what I argued with myself. Guys, what do you say about this? I want to open the room and literally apply you guys to this question. Is this an endothermic reaction or an exothermic reaction? Why are you saying exothermic? Yes, sir.
After the experiment, the surroundings are hotter than it was before. The temperature raises.
Okay. Which surroundings are there? Which one is the surrounding here? From 20 to 34, there is an increase in temperature. Is that for the reaction or it's for the surrounding? So if the reaction increased temperature, doesn't it mean it absorbed energy? So isn't that an endothermic reaction? The reaction temperature increased in here. So this is an endothermic reaction. Yes, ma'am.
So because most of the time when we ask this question, they give us the enthalpy change. Can we say that the change in temperature is similar to the change?
So enthalpy, you also need to remember, enthalpy talks about heat absorbed or heat lost. Do we have an enthalpy there? So look into the reaction itself. What is happening? It's like putting sodium chloride plus water, and then you touch the flask like this, right? You feel like the temperature is getting warmer. Is that okay? What does this mean? It means the temperature is increasing, it's absorbing energy from the surrounding. That means the reaction is an endothermic reaction. Think about a volcano. A volcano releases energy, it becomes colder. That is an exothermic reaction. Okay? So please be able to answer that question. We say this reaction is an endothermic reaction. Why? Because it absorbed heat from the surrounding, so it became what? Endothermic, because the temperature what? Increased. Are we lost? Thank you. And then now we say we need to quickly move. Time is really moving. All right. So now they say, give reason why there is a different rate in experiment 1 and 2. If you look at experiment 1 and 2, why is there a different rate? Look into the form. The other one is in a granular form. Is that okay? The other one is in a powder form. Do you see that the powder one took only 10 seconds to finish? The other one took longer. Is that okay? What would you say if I wasn't there in that test? So the other one is in a granular form, the other one is in a powder form. 1 mark. The other one has got a larger surface area, the other one has lesser surface area. Is that okay? What the surface area has to do with the rate of the reaction. Because you need to keep on explaining till you feel like I've explained enough. Okay? Don't just leave stuff half marks. Try to put everything down into the paper, okay? So what I want you to do there, you say, they didn't want you to explain, they just said, why is there a difference? You say now, there's a larger surface area in the powdered form over the granular form. Is that okay? So reaction 1 is slower than reaction number 2. The learners compare the results in experiment 1 and 3. Let's look at experiment 1 and 3. Experiment 1 and 3. Okay, and then the conclusion regarding the effect of the concentration on the reaction rate. Give reason why it's not a fair comparison. The learners compare reaction number 1 and 3. Okay, and then now reaction number 1 and 3. The other one is in a powder form. The other one is in a granular form. Do you guys see that? And then now they say give reason why it's not a fair comparison. It is not a fair comparison because you're comparing two things that are in different forms. Do you guys understand that? And then you can also talk about the concentrations as well. I just thought about this easy, quick one as well. Is that okay? So it is not a fair comparison because they are looking at things at different states and different concentrations. That's how you get the mark there. Different what? I will say different forms. Is that okay? Let me use the correct one. Different forms. The other one is in a what? Powder form. The other one is in a granular form. And also different concentrations. The other one is 0.8, the other one is 0.5. Okay, good stuff, we move on. And then now they say, how does the rate of reaction rate in experiment 5 equals to the rate of reaction in experiment 1? How does the rate of reaction in experiment 5 compares to the rate of reaction in experiment 1? How is it right, either faster or slower or equal to? Experiment 1 and 5. If you look at experiment 1 and 5, do you see that we have granules? We also have granules. Do you see that we also have what? The same one? But now looking into the temperature, guys. Do you see that the temperature change is also the same? So what would you then say they're looking into the time? It's faster. Which one is faster? Experiment what? 5. And then you need to then explain why is that. There is a use of a what? What does a catalyst do? It lowers activation energy. That means it drives the reaction faster. If it drives the reaction faster, that means if it lowers the activation energy, don't forget, lowers the activation energy, that means the molecules are going to move what? Fast. Once the molecules move fast, that means they collide with each other faster, right? When they collide with each other faster, it means the reaction is fast in general. Explain till you fall there. You see how many marks are there? So you can't just say it just makes the reaction fast. You then need to say, oh, it lowers the activation energy. Once it lowers the activation energy, it means that now the molecules are moving faster. That means they collide with each other faster. That means what happens? The reaction is fast at the very end of the day. Are we good? Because I feel like if I write that, it will take so much time. Please apply yourself to it. Talk about it. Know the factors. The factors, I think I wrote them somewhere here. If you speak about this, you should be fine. Okay? Yes or no? Please speak about that. I think Temba, I organized Temba to organize the memo for this. He will send it to you. Okay? And then now, the last question. This one. Calculate the rate at which the hydrochloric acid in reaction number 4 calculated in mole per second. This means moles per time. Do you guys understand that? In experiment number what? 4. Do you guys see that experiment number 4, you already have the time as what? As 8. What does this mean then? Calculate what? Moles of what? Hydrochloric what? Do you have information about hydrochloric acid, good people? Do you have its moles? But you do have the moles of zinc. Do you guys see that you have the moles of zinc because you have what? The mass of zinc. And then if you know zinc, it means you can look into the periodic table and find what? Its molar mass. Once they give you the formula, they're giving you what? The molar mass. Once you have the mass and molar mass, you have got moles. Once you have got concentration and volume, you also have what? Moles. Because I want you guys to apply yourself into that. So, number of moles is equal to the mass all over the molar mass. Or you can say, some people, they say number of moles is equal to small m all over big M. I'm not going to penalize you depending on what your teacher told you. Okay? And then also, don't forget that concentration is number of moles over volume. Therefore, number of moles is equal to concentration times volume. Don't forget that the volume is in dm cubed or it's in liters. Yes or no? The concentration is in moles per liter, not moles per cm cubed. Are we together? you convert everything. So if you have either the mass and the molar mass, you have number of moles. If you've got the concentration and the volume, you have moles. They could give you the zinc and say zinc is a liquid, and then it has got this concentration and what? Volume. So that means they gave you what? The moles. Once you know the number of moles of zinc, guys, according to this question, you eventually know the number of moles of HCl using the stoichiometric ratio. Do you guys want to calculate it? Let me let you guys do it. I'm giving you a second. The molar mass of zinc, I'll give it to you now. It's 65. Let me let you guys try it so that you are good at it, okay? So the trick to answering any question paper in this world, when they say 2 marks, it means 2 minutes, okay? Train yourself to think like that. If they say 6 marks, that means spend 6 minutes in that. Is that okay? Try to always work faster. Some people don't do well not because they're not clever. They don't do well because of time. Is that okay? So always try to work smart, not hard. Okay? Time yourself all the time. So all you then need to do there is to come back and say number of moles of zinc is given by mass all over what? Molar mass. In this case, it is 1.2 grams divided by 65 grams per mole. You know what I always say? Don't just say 65. Just say 65 grams per mole while you're trying to show them that I understand that is the molar mass. Is that okay? Because some people will be like, so how did you know that this is 65? What does this 65 actually means? Is it okay? So show that you understand that this means molar mass. And then once you calculate that, you should be able to get 0.0181 moles. These are moles of what? Of zinc. But you're looking for the moles of hydrochloric acid. Do you guys understand that? So if you want to be very, very clever about it, you could say zinc is to HCl. Do you guys understand that? Yes. And then once you say zinc is to HCl, you say HCl there is 2, zinc is 1. You write the stoichiometric factor, yes or no? Yes. So if you know that zinc is equals to 0.018, you say X. Is that okay? You do the whole thing of cross multiplying, and then once you've done that, you say X is equals to 2 times 0.018 moles. Is that okay? And then the moles that you will get there are what? 0.037, right? Yes. 37 moles of what? HCl. Is that okay? So you have the moles of HCl. What did the question want? What did the question want, good people? Calculate the rate, and the rate is given by mole per unit time. So we have the mass, the moles. You guys see that? So therefore, the rate is given by the number of moles divided by the time. The number of moles there are given as 0.037 moles divided by the time. In this case, the time is 8. Do you guys all see that? The time is 8 on the question, and then we say this is given by 8. Don't forget that the time is in seconds, and the units that they want there are in seconds. If they said minutes, that means convert that 8 seconds into what? Minutes. Do you guys understand that? Means change of mole per minute. That means convert that 8 seconds into what? Minutes. Do you guys know how to do that? So the final answer that I expect you to write for me there is equals to 4.63 times 10 to the negative 3. What is this? Mole per second, which is the unit that the question wanted, and you are good to go. Question is, or the trick to this, as I've been saying, use what you don't have to get what you have using stoichiometric ratios. Because some people are like, so how do I calculate HCl? But look into the question, you are given zinc, and zinc and HCl are cousins through a stoichiometric ratio. Is that okay? always try to use that. Always check the equation if it's balanced. Is that okay? Don't assume it's balanced for you because you will definitely sink. Is that okay?